So these are the subjects that'll be on the quiz tomorrow, or not tomorrow, Wednesday. Move that up for a second. Today we are going to talk about when you have multiple functions, you need to combine them together. There's a few different ways you can do this. Okay, so when you combine together functions, okay, one of the primary ways is just using arithmetic. In other words, adding, subtracting, multiplying, and dividing them. Okay. The nice thing about these are fairly straightforward. It's just manipulations of those functions together. Okay, again, this box is straight out of your book. Okay. Now, they will use slightly different symbology for this. It will look like they're adding the f and g together, which just means add up the two functions. Subtracting, same thing. Multiplication, same thing. They're just separating them out. Okay? Basically, it's just a shorthand way to write it. But the idea for this is that if I have these two functions, they don't have to have anything that actually combines together. It just creates a new polynomial. So if you're doing f plus g of x and you're given these two polynomials for f and g, well, when I combine them together, what would that end up looking like in this case? If I add them together. Don't overcomplicate this. Yeah.
X squared minus x plus 1.
Yep, literally just put the pieces in descending order and combine all like terms. Okay. Then if they ask you to evaluate at a given sum, what they're asking then is f plus g of x, but instead of fx, it's of 2. Now, the nice thing about this, you either plug it in before or after. It does not matter. If you plug it into both of these and then add up the individual components, so if I plug in 2 here, 2 squared, 1 minus 2 gives you, add them together, gives you 3, right? Okay. So for this, x squared, if I plug in this way, that's going to give me 4 minus 2 plus 1. Gives you the same thing either way. You end up with 3. Okay? And honestly, on an example like that, it's kind of easy as far as the pieces go. They will basically end up being that way because all you're talking about is adding together. It's just going to be combining like terms. Subtraction works almost the exact same way. If I have the same two f and g functions, but now I'm subtracting them. Well, the only thing different is going to be what? Say again? Yeah, the sign's on the second part. So it's x squared plus x minus 1. Your favorite guys, and you yell at me when you're talking. So f minus g of 3 will give you what?
9 plus 3 minus 1 is 11.
Should get 11. Okay. Multiplication. Now, here's a little bit of a downside of multiplication of polynomials. Well, yeah, you pretty much got a FOIL, but if they're longer form, you got to deal with the distribution there too. Okay? So, if I FOIL these out, f of g of x, or no, sorry, f times g of x. So if I multiply them out, what do I get?
X squared minus
Negative 14x minus 8.
Minus 14x, yep, minus 8. So this is a case where if I'm doing, and honestly 2 is not that bad of one, but f of g of 2, or f times g of 2, I keep saying that wrong. I would honestly probably plug it into the original instead. Because that's going to be the same thing as f of 2 plus g of 2. And what's f of 2?
12.
12. What's g of 2? 2. So your answer is? No, yeah, times. Why did I write plus? Thank you. Wow, it's Monday. 12 times 2 is 24. And you can see, if I plug that in here, it's going to be 15 times 4. What's 15 times 4? 60. 14 times 2?
28.
28. So if it's negative 28 minus 8, will be negative what? Negative 36, and 64, or 60 I should say. Why did I say, because I saw the 4. 60 minus 36 gives you the 24. So use your calculator. All right. Division. Now, the good and bad part about division. When we're talking about polynomials, unless they factor and simplify out a little bit, there are a lot of times you're not going to be able to do anything with them. If I have f divided by g of x, all that is x squared over 1 minus x. I can't do anything with it. Okay. What about f divided by g of 3? I know. 9 over negative 2. That's your answer. Now, one thing though, I did actually skip something on the previous part. What do I have to include with this?
When x is not equal to 1.
Yep. X can't be 1. You do need to include that with the division ones. Okay, and anything where you have that kind of denominator going on. Questions so far? Not too bad? Okay. Another way to combine together functions is actually to use the composition of functions. What this means, and they'll use a symbol where it's an open circle between f and g. And the way that's read is f of g of x. Remember this vaguely from last year?
Yeah.
All right. All it means is you substitute one into the other. Now, they give you a mapping version of this, which is if you're talking about individual values, oftentimes instead of combining, doing the composition of the functions, it can be easier, especially if you're doing one case in isolation, to take whatever the original value is, plug it into the g function, then plug it into the f function, that result, into the f function. Or you can just bypass the whole thing by creating another function. Now, if you're going to do iterations of 60, 70 things, now we're not going to do that in here, but the idea is it'd be usually more time efficient to create a new function to do it rather than do multiple functions combined. So if I have these two functions, and I want to do the composition f of g of x, okay? So looking at that, f of g of x, well, I'm going to rewrite it first just because honestly it makes it easier not to screw up for me. If I rewrite this as f of g of x, that notation, and the book will primarily use this one, but they do talk about this one, that notation very blatantly shows you that it's inside, that the g function is inside the f function. Okay? So then when I go to do that, what would I actually write for the function? Or what would I substitute where?
2 times 4x squared plus 1 plus 1.
Yeah, you're taking the 4x squared into the x over here. So 2 times the quantity, 4x squared plus 1 plus 5. Then simplify it. What's that going to simplify out to?
8x squared plus 2, or plus 7.
8x squared plus 2 plus 5 gives you 8x squared plus 7. Okay? What about when it's the other way? G of f of x. So I'm going to substitute the other way. I'm going to take the x out of the g function and replace it with 2x plus 5. So I have that squared and then add 1 to it. Well, what's 2x plus 5 squared going to give me?
4x squared plus 20x
Plus 20x
plus 25.
plus 25. Okay? Then simplify from there.
16 squared 80x plus
16 is x squared plus 40x plus 26.
101.
All right. What's going on there? Make sure the 4 distributes to everything in the parentheses, not just the first term. Okay? So it's going to be,
Yeah.
so yeah, 16x squared plus 80x plus 100 plus the 1. So plus 101. Questions on those? Now, when you're doing this, f of g of a specific number, of negative 1/2, for instance. Okay, so this is going back to the first function. I can just plug this right into this function, because this is the same as that f of g of negative 1/2. Now when I do that, this first function I came up with, well, that gives me 8 times negative 1/2 squared plus 7. Well, what's negative 1/2 squared without the calculator?
1/4.
Positive or negative?
Positive.
Positive 1/4. And what's 1/4 of 8?
2.
Plus 7 is
9.
9. Okay? Now, sometimes though, if I have the same function but reversed, g of f of negative 1/2, well, this final form of that might be a little bit of a hassle to plug in. Okay? So instead, I'm going to go back to this. I'm going to treat this, well, you have g of f of negative 1/2. So I'm going to do the f of negative 1/2. What's 2 times negative 1/2 plus 5?
4.
4. That's going to give you negative 1 plus 5, or 4. And g of 4, I'm going to plug that into the g function. What's that going to give me?
65.
65. 4 squared is 16. 16 times 4 is 64. 65. Questions? Okay. A couple more real quick. These are actually a little bit easier. But sometimes, though, things don't combine together nicely. But there isn't too much you can do with them. F of g of x in this case would look like what when I combine them?
In the square root of x squared plus 4.
You remember what the name of the symbol is?
Oh, the radical.
Radical? Yeah. Square root of x squared plus 4. What does that simplify to? So x plus 2 times x plus 2 is x squared plus 4? No. This one you can't actually do anything with. Does not go any further. Because you can't square root both pieces independently because of the plus sign there.
Why is the radical over like the whole thing now?
Because it's, remember, it's f of the g of x, right? So I'm taking the g function and putting it into the f function. So if I'm doing this, well, I'm ripping out the x from here, which is under the radical, right? The x is entirely under the radical, so that means the g of x, when you plug it in, will be entirely under the radical. So that's why it's the square root of the whole thing. So then what would the domain of that function be? Of the resulting function? Are there any x values that would not work for that?
Negative. Wait.
Negative wouldn't work?
So we're being the
Yeah, it would be, because when you square a negative, what happens? Turns positive. So the thing is, this will never be a negative under here, no matter what number you put in, right? So the domain then is
all real numbers.
all real numbers. Okay. Now this is kind of working backwards. Find two functions f such that f of g of x is the cubed root of 8 minus x over 5. So the way you want to think of this, which function here, according to this statement, is on the inside? G of x. So typically what I'll do is find that one first. Now what would be a good function, a good combination that makes a function to pull out of that? That's inside of something else.
8 minus x.
Yeah, I see a radical there. That's a convenient thing to pull that value out, 8 minus x. What would the f function have to look like then?
The cube root of x.
Yep, cube root of x over 5. That's all those are. That's all there is to those kind. Okay. One more. The weekly cost of producing X units in a manufacturing process is given by the C of X formula. The number of units produced in T hours is given by X of T equals 40T. Find and interpret what C of X of T means. Okay. So let's find that value first. I'm going to rewrite this as C of X of T. What would you do? It's just the composition stuff, right? So which one is on the inside? X of T. Okay, right? So then I'm going to put this 40T where?
For the x.
X in the other equation. So I'm going to take 48 times 40T plus 1150. What do you get when you simplify it?
$19.20p.
1920T plus the 1150. Now, what does that mean? What is that formula finding you? Because this top one, it's given to you as finding the cost, right? Per units produced. This one's the number of units produced in that many hours. So what is that finding? The total cost? Of what?
Is it the weekly cost in T hours?
Well, would it even have to be weekly?
Daily.
The 1150 implies that you could say something like that. Weekly cost in T hours or 4 T hours. Yeah, that would work. I phrased it a little bit differently, but that works as well. Questions on any of it? Okay. Rest of the time is yours. Quiz is on Wednesday. Make sure you're ready.